Alright, welcome to Colossus mathematics class. Don't forget to subscribe, like, and share this video. Today we'll be talking about complex analysis. Well, this is the second section on complex analysis, and today we are going to be talking about conjugate of a complex number. Don't forget, a complex number is in the form z equals to x plus iy, and then its conjugate, which is represented with z bar, is x. If this is plus, its conjugate will be what? Minus iy. Now we want to run through some properties of conjugate of a complex number. Now the first property states that the addition of a complex number with its conjugate will give us a real part. It give a real part. Now let's check that. How true is this? Let's say our z plus our z bar, that what? What's our z? X plus iy, plus our z bar is what? X minus iy. Now let's see whether we are going to have a real part. So that will be x plus iy plus x minus iy, right? And that will have what? X plus x. This will cancel this, so x plus x will give us what? 2x. And you can see that this is only a real part. So this has satisfied the property that a complex number added to its conjugate will give us a real part. Now let's see that. Let's say I have a complex number z equals to 2 plus, let's say 2 minus 5i. 2 minus 5i. Now the conjugate of this one will be what? 2 plus 5i. Now let's check through that. That will now be z plus z bar. That will be what? 2 minus 5i plus 2 plus 5i. That what? 2 minus 5i plus 2 plus 5i, right? 2 plus 2 will give us what? 4. Minus 5i will cancel minus 5i, and that is giving us 4, which is only what? A real number. Do we get that now? So addition of a complex number with its conjugate will give us a real number. Now the second property says a complex number minus its conjugate will give us imaginary, will give us an imaginary part. Now we want to check how true this is also. So let's, our z minus our z bar, our z is what? X plus iy, minus our z bar is what? X minus what? Iy. Now x plus iy, minus times plus will give us minus, minus times minus will give us what? This is x rather. Minus times minus will give us plus what? Iy. And that will give us, our x will cancel minus x, I and iy, so that will 2iy. And you can see that this is an imaginary part. Do we get that now? So this is an imaginary part. So let's use this same example. I'm using this same example now to show that our z minus our z bar will give us a real part. So what's our z? Our z is 2 minus 5i minus 2 plus 5i. So that would be what? 2 minus 5i, minus times plus will give us minus 2, minus times plus will give us minus what? 5i. Now you can see that plus 2 will cancel minus 2, and minus 5 will give us minus 10i. You can see that it is an imaginary part. Do we get that also? Then the last property, which is product, that the product of a complex number with its conjugate, the product of a complex number with its conjugate will give us a positive, the multiplication of a complex number with its conjugate will give us a positive real part. Let's see that. A positive real part. Real part. So let's see that. Let's say I have where is it? Z, our Z multiplied by our Z bar, which is x plus iy multiplied by x minus iy. Now let's see that. X times x will give us what? X squared. X times minus iy will give us minus xiy, plus iy times this will give us plus xiy, plus times plus will give us minus, plus times minus will give us minus, I times I will give us minus 1, y times y will give us what? Y squared. I'm sure you understand what I did there. I plus times minus, minus, I times I minus 1, y times y squared. So that will be s squared. Now minus xiy plus xiy will cancel each other. Minus times minus will give us plus. 1 times y squared give us what? Y squared. So we can see that this is a positive real part. So you can go ahead and use this example to try it. You will get the same thing. So thank you very much. Watch out for the next episode as we continue on complex analysis. Thank you very much. Don't forget to subscribe, like, and share this video. Thank you.